Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket for confidence intervals for means when we're working for a Z. So here we're going back to the scenario that we did in the warm-up, which was say ah. This is a large urgent care network prescribes the same antibiotic to more than 9,000 adults each year. By the way, this is my population. This is not my sample size. That's my population. I should have said that in the first video. For uncomplicated strep throat, you take a simple random sample of 41. So our sample size is 41, who complete the prescription and record the time and hours until their sore throat symptoms noticeably improve and are able to swallow comfortably. The sample's mean time is 29.4. So this is our X bar, and this is 29.4. Assume the population standard deviation is 10.2. So our population standard deviation is 10.2. We have to have that, otherwise we're not working with a Z-test. And they wanted us to calculate a 96% confidence interval. So we did that. So we're going to refer back to what we've done already. We're going to go back to our parameter because we're going to need this. Let mu equal the true population mean time until patient sore throat symptoms improved. And when we actually ran this thing in our warm-up, we got a confidence interval of 26.128 and 32.62. I'm going to go ahead and write that down. So our interval is 26.128. We got this from our warm-up. Go back to that if you have questions about it. Where this is my lower, this is my upper, and we're centered on, this was 96% right here, and we're centered on our mean of 29.4. So we have to do our conditions. The first conditions, random sample of 41. So in this case, we're good. N is greater than or equal to 30. Because they didn't tell us it was normal, so we need to make sure that we make that note. N is greater than or equal to 30. All right. Now we need to make sure that our sample size isn't too large. Okay. So this is telling us it's large enough. So this is 41. That's our sample size. We multiply it by 10, always times 10, and that's less than 10% of the population. So N is less than 10% of the population. That's what you're checking. Here, big enough. Here's not too big. And then finally, we need to go, N is 41, so normal by central limit theorem. And that's what I was putting there. All right. And this can be a greater than or equal to. So it can equal 30. So this could have a line underneath it. But normal by central limit theorem. So random sample, yep, we took it random. That's what was important. Don't have to say this part. Oh, and we should say that this was given. So random sample of 41, it was given. It was big. So in this case, it wasn't too big. In this case, it's big enough. So not too big and big enough. All right. So how do we write this? Well, we are 96% confident the true population mean time until patient sore throat improved. And remember, we got that from our warm-up. Lie within our interval. We also did that in the warm-up of 26.128 and 32.672. All right. And then what is the meaning of the confidence level? In repeated sampling, we expect this method to capture the true population mean time until patient sore throats improve 96% of the time. Please remember that when we do this right here that I'm highlighting comes straight off of our parameter. Look at that. True population mean time until patient sore throats symptoms improve. True population mean time until patient sore throat symptoms improve. Exactly the same, came straight from restating our parameter. All right, I hope this helped. Look forward to seeing you on the next one. Thank you.